In this section, we're going to talk about Ethernet. As we discussed in our previous section, Ethernet is the most widely installed local area network technology. Ethernet is a protocol in describing how network devices can format data for transmission to other network devices on the same network segment and how to put data on our network connection. Again, as we talked before, data link layer has two sublayers, and they are LLC, logical link control, and MAC, media access control. LLC organizes communication with upper lower layers and provides common interface reliability and flow control. And MAC appends physical address to frame and provides data encapsulation and error detection. Let's go ahead with the collision domain term. A collision domain is a network segment connected by a shared medium or through repeaters where data packets may collide with one another while being sent. A network collision occurs when more than one device attempts to send a packet on a network segment at the same time. Members of a collision domain may be involved in collision with one another. Guys, only one device in the collision domain may transmit at any one time, and the other devices in the domain listen to the network and refrain from transmitting while others are already transmitting in order to avoid collisions. Because only one device may be transmitting at any one time, total network bandwidth is shared among all devices on the collision domain. Collisions also decrease the network efficiency on a collision domain, as collisions require devices to abort transmission and retransmit at a later time. Collisions are often in a hub environment because each port on a hub is in the same collision domain. By contrast, each port on a bridge, a switch, or a router is in a separate collision domain. As you can see in here, we have a switch, and this switch has four different ports. Each port of the switch is a separate collision domain. As you can see in here, this is collision domain 1, this is collision domain 3, this is collision domain 2, and this is collision domain 4. But as you can see in here, separate ports of the hub is not a separate collision domain. All ports of the hub are in the same collision domain, which is collision domain 4 in here. In a shared media, devices may want to send data at the same time. Carrier sense multiple access (CSMA) method is used for sharing the media, but collisions may occur if two devices try to send data at the same time. On the screen, as you can see, that all workstations are saying that I send my data whenever I want, and they don't want to share the media. So we have a method named CSMA-CD, CSMA collision detection, used for detecting collisions for Ethernet networks. Logic behind this is check media. If it is free, send. If not, wait for idle and send again later. For example, in here, if workstation A wants to communicate with the server, it sends a message saying that I need to send something. Is there anything currently on the wire or not? CSMA-CAE is used for detecting collisions for wireless networks. Logic behind this is check media. If it is free, send a notification to use it and then send your data. And here how is going on. For example, if this tablet wants to send data to a wireless medium, it's checking the data, checking the medium, first. Then it's sending a notification to the medium saying that, hey guys, I'm gonna send the data. Then it's sending whatever it's gonna send. And let's take a look to the Ethernet frame now. In the first fields of Ethernet, we have preamble and SFD. These fields provide synchronization between source and the destination devices. Secondly, we have destination and source address fields, and they are the source and destination MAC address info. And the other field is the VLAN tag, which is used for quality of services and carries the VLAN information. That's an optional field. And the other field is length and type, which keeps the length of data and the type of the protocol we are using. And another field is the data field, which keeps the encapsulated data information from OSI layer 3. And the last field is FCS, frame check sequence, and frame check sequence bits must match for source and destination if no error occurred, and this field is used for the error detection. Let's take a look to the MAC address now. A media access control MAC address of a device is a 48-bit unique identifier assigned to network interfaces for communications at the data link layer of a network segment. MAC addresses are used as a network address for most network technologies, including Ethernet and Wi-Fi. MAC addresses are shown in hexadecimal format, guys. Hexadecimal is a position numeral system with a radix or base of 16. It uses 16 distinct symbols, most often the symbols from 0 to 9 to represent values from 0 to 9, as you can see in here. And A, B, C, D, and E and F to represent values from 10 to 15. MAC addresses are assigned to network devices such as PCs, printers, servers, and etc. and consists of two portions, as you can see in here. The first portion is OUI and the second is UAA, or Extended or Device Identifier. The first portion is OUI, an organizationally unique identifier. OUI is 24-bit number that uniquely identifies a vendor, manufacturer, or other organization. The second portion is UAA, or Extended Device Identifier. This is a number unique to the vendor. For example, let's say that this first portion is unique for example, maybe Intel, maybe Qualcomm. Then the MAC addresses that Intel manufactures or Qualcomm manufactures are finishing with the arbitrary numbers that the Intel or Qualcomm says. MAC addresses can be represented in three ways mostly. The first, dots are used between each four characters, as you can see, as in here. And the second, dashes are used between each two characters, like here you can see as well. And in the third, double columns are used between each two characters. There are also three different types of Ethernet addresses, and they are unicast, multicast, and the broadcast. A unicast frame contains the unique MAC address of the destination receiver, and unicast address frame is only send out the specific port leading to the receiver. For example, if this computer 1, wants to communicate with computer 3 over the switch, and if this is a unicast, frame is going to here but not here and forwarded to here. A multicast frame contains the unique multicast MAC address of an application, protocol, or data stream. A multicast address frame is either flooded out all ports if no multicast optimization is configured, or sends out only the ports interested in receiving the traffic. If you want to send a multicast layer 2 traffic, your destination MAC should start with 0100 and 5E. And let's talk about the broadcast MAC address. A broadcast frame is flooded out all ports. A broadcast frame contains all binary ones as the destination address, which is FF, 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 and FF. For example, if this guy wants to communicate with all these other guys, the source address of the Ethernet frame is this guy's MAC address, and the destination gonna be here. Let's go ahead with the ARP. Address Resolution Protocol, ARP, is used for resolution of IP address into MAC address. ARP request is made via broadcast to FFFF, 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 and ARP reply is made by related device as unicast. For example, if PC1 sends an ARP request, this message is broadcast. Comes to here and comes to here. And let's say that PC1 is researching the physical address of the station that has the IP address 21.3, which is PC3. PC3 takes this request and replies back with its MAC address, and this packet is just sent to PC1 as unicast. Let's take a look to the ARP table. On networking devices, a table usually called ARP cache or ARP table is used to maintain a correlation between each MAC address and its corresponding IP address. ARP provides the protocol rules for making this correlation and providing address conversion in both directions. In here you are seeing an ARP table of a router, and in here you are seeing an ARP table of a PC. The command that we are using is show IP ARP command to display the ARP cache of a router, and as you can see in here we are seeing the IP addresses and the MAC addresses of the same device on the table. Let's go ahead with the LAN switch. A local area network switch is a networking device that connects devices together on a computer network by using packet switching to receive, process, and forward data to the destination device. Switches mostly operate at layer 2 of the OSI module and provide switching according to MAC address using MAC address table. On the local area network switch, there is a table called MAC address table, and what layer 2 switch is making is just switching between different ports by using MAC address information located in the MAC address table. Let's see how MAC address table is established on a switch right now. Firstly, the MAC address table is empty. This is the switch, guys, and MAC address table is empty, as you can see. In the first step, if PC1 wants to forward a packet to PC2, switch flutes it out of all ports and adds PC1's MAC address to its MAC address table. What is going on in here is PC1 wants to communicate with PC2, switch checks the frame and then checks the MAC address and immediately adds the PC1's MAC address to the MAC address table and saying that, hey, on my first port I have a MAC address of this, wants to communicate with this MAC address, but I don't have this MAC address on this table, so I'm fluting the request out from all my ports. Then let's say that PC2 sends a unicast reply to PC1 and switch adds the PC2's MAC address to MAC address table 2. Then, after this process, if PC1 wants to send the data to PC2, frame is forwarded directly. In the end of the day, switch learns all of MAC addresses connected to all of its ports and establishes a full MAC address table, as you can see in here. And saying that on my first port I have this MAC address, on my third port I have this MAC address, on my fourth this, seventh this, and eighth this. From now on, if this PC5 wants to communicate with PC1, frame is directly forwarded to PC1. Let's go ahead with the duplex options. We have two duplex options, half duplex and full duplex. Half duplex is used to describe communication where only one side can send data at a time. Once one side has finished transmitting its data, the other side can respond. Only one node can send data at a time in half duplex. If both try to send data at the same time, a collision will occur in the network. On the other hand, full duplex is used to describe communication between where both sides are able to send and receive data at the same time. In these cases, there is no danger of a collision and therefore the transfer of data is completed much faster. Let's go ahead with the Auto MDX feature. In today's networks, using the proper cable type is very important, guys, and certain devices has a great feature to help us preventing wrong cabling. Auto MDX ports on a newer network interfaces detect if the connection would require a crossover and automatically chooses the MDI or MDIX configuration to properly match the other end of the link. And let's take a look to the frame forwarding types. We have 3 frame forwarding types when we are forwarding a frame in our switch. And they are store and forward, cut through, and cut through fragment free. In store and forward method, frame is forwarded after the whole frame received and there is no CRC. In cut through fast forward, frame is forwarded after the destination MAC address is checked, and in cut through fragment free, frame is forwarded after 64 bytes of the frame is checked. Let's go ahead with the PoE, Power over Ethernet now. Power over Ethernet describes any systems which pass electric power along with data on twisted pair Ethernet cabling. This allows a single cable to provide both data connection and electric power to devices such as wireless access points, IP cameras, and VoIP phones. To provide electric over data cables to end devices, and devices also must be supporting PoE technologies too. In here we are seeing a PoE switch, and we have an access point, IP camera, industrial sensor, and VoIP phone connected to our PoE switch. If this switch is supporting PoE and also this VoIP phone, sensor, IP camera, and access point are supporting the PoE feature too, we don't need an extra power cable, we don't need an extra power adapter, we don't need anything else. We can provide the power of these devices by using the twisted pair copper cables. Let's take a look to the fixed and modular switch. These are the types of the switch, guys. Fixed configuration switches are fixed in their configuration. What that means is that you cannot add features or options to the switch beyond those that originally came with the switch. The particular module you purchase determines the features and options available. For example, if you purchase a 24-port gigabit Ethernet fixed switch, you cannot add additional ports when you need them. There are typically different configuration choices that vary in how many and what types of ports are included. And let's take a look to the modular switches. Modular switches offer more flexibility in their configuration. Modular switches typically come with different size chassis that allow for the installation of different number of modular line cards. The line cards actually contain the ports. The line card fits into the switch chassis like expansion cards fit into a PC. The larger the chassis, the more modules it can support, and mostly these modular switches can carry high traffic. And let's take a look at a great feature, which is stack technology. A stackable switch is a network switch that is fully functional, operating standalone, but which can also be set up to operate together with one or more other network switches. With this group of switches showing the characteristic of a single switch, but having the port capacity of some combined switches. The term stack refers to a group of switches that have been set up in this way. The common characteristic of a stack acting as a single switch is that there is a single IP address for remote administration of the stack as a whole, not an IP address for the administration for each unique stack. And then lastly, we are going to talk about SFP, small form factor pluggable. The small form factor pluggable is a compact, hot pluggable optical module transceiver used for both telecommunication and data communications applications. An SFP interface, this guy on networking hardware, provides the device with a modular interface that the user can easily adapt to various fiber optic and copper networking standards. This is a fiber optic SFP, and there are also types of this SFP which supports the copper cables as well.